Okay, salam Dr. Jujura Doctor. My name is Ying Jie and I'm from RY32 Group 1. So right here I'm going to present about my lab test. So we're going to start with our first question. Okay. So first question, we are asked to get the output signal of Yn by using convolution. Okay. So remember that our convolution uh, equation is this one. Okay. So here the most important one is we need to know how to determine xn and hn. I mean, for this one, the coding of x and h. Okay, so for x, we are going to determine by this. So firstly, we are going to find the time frame. Time frame we are going to find from the end. So for first one, n equals to 0. There's nothing beside n, so 0. And then here, n minus 1 equals to 0. So n equals to 1. Okay, same to here, n equals to 5. So our time frame will be 0, 1, 2, 3, 4, 5. Okay. So after this, we are going to find the number for your delta. So first one, when n equals to 0, your delta will be 1. N equals to 1, your delta will be this is 6. Oh, I'm sorry, negative 6. And then when n equals to 5, your delta will be 1 again. So for the rest of it, it will be 0 for the time frame. Okay, so here is how you will get your x. And next, we are going to the h. It is actually the same method. Okay, let me delete this. Okay, to get some spaces. Alright, so go to hn. Again, let's check our time frame. And, oh sorry, I shouldn't write it here. Okay, so for n equals to 0, there's nothing. And then n equals to 3. So our time frame will be 0, 1, 2, and 3. When n equals to 0, your u is 1. And then when n equals to 3, it's negative 1. So for the time frame 1 and 2, there's nothing, so we are going to put 0. And yes, by doing like this, you will get your h, the coding for h. Okay, so after done getting your information, you can code in just like this. And this is the formula of it, and then to create the time frame, to create the signal later in the graph. And then about the figure 1, which means that it will pop out the window. How many windows are we going to have? From here, we are going to have 2 because I have figure 1 and also figure 2. Okay, next is the subplot. So subplot basically is for you to plotting the graph, like the position of the graph. Like 1 to 1 means that I'm going to have 2 graphs in the horizontal arrangement. And then step is for you to plot the discrete time signal. Okay, and then the next thing is this color, this thing. This blue, green, red is the color of my graph, and then the line width I put 2 so that it can show a thicker line, so you can see the result clearly, more clear lah. And okay, until here everything's also the title. The title thing is for you to label your graph, and the next one is the equation for your convolution. And again, this is the plotting, how many plot are you how many responses are you going to take, and yeah, just like that for the code should be done, explained, and we are going to run. And please wait for a while because my computer is not that good. Okay, yeah, so here our signal. Okay, for figure 1, I have put my xn and hn inside a figure. So this is the signal plotting for xn and the hn. So figure 2 will be my output signal yn, which is after the convolution, and here's my result for question 1. So right now I'm going to the next question, which is question 2. So question 2, we are asked to find the partial fraction and also the time domain transformation for xs. Okay, so here we're going to the question 2. Okay, a very quick introduction for a and b is the numerator and denominator of my equation. So a, we can get it this one, the numbers from our numerator, which is 1 and 5. So we can see from the largest power lah, until the smaller thing. So right here, the largest power for our numerator is s, and then the number of s is 1 because there's nothing in front of it, which means 1s, 1s equals to s. So the number is 1. And then the denominator, again, s power 3, 1 s power 3, so you get 1 in here, and then s power 2 is 7, s is 8, and plus 0. Correct or not? Like, you see, you have the last digit at here. So when it don't have means plus 0, usually we won't write out the plus 0 right here. So remember to put in the 0. Okay, and then next we are going to get the this formula to calculate our RPK, and the RPK stand for residue poles and constant, and this one same as means is our S domain. Yeah. So right here, this one is our formula equation of this. About why I use polysim is that I can reduce my work of typing out the equation. So poly to sim is AS, which means I sub this into my here, which is the numerator, and this one is the denominator. I sub the thing to here, and then here's the output for the calculation thing, command, and we run it. Okay, so here's the output. I will show you in my Word. It will be more clear to be seen lah. Let's go to here. Okay, so you can see this is the golden, this is the output. So output we will get our this fs and also our partial fraction right here. So we have two output right here. Actually is the same thing lah, just this one is in a bracket form, like every time we write in our hand, like every time we do our handwriting, and this is the usually we type out the thing lah. So yeah, and here I can say something here. This is our book. Yeah. So that's all for my question 2, and we're going to question 3. So question 3, we are asked to plot the poles and zero signal. I mean the graph in the S-plane. So here's the command. So firstly we get our equation in time domain. So we must declare the Sims t, which is this thing is in time domain. And then after that we code our equation, and then code this one to make it become HS. So later we can put it our S-plane, our S domain. Okay, after that we are going to our S domain, Sims S, and then N and D stand for the numerator and denominator of HS. I got this one lah, to let the system to recognize to remember my to remember my N and D. And again polysim, so I no need to code in the system will automatically code in everything, like taking sub all the numerator and denominator into the formula, into the equation, and we'll use RPK to get the poles, the number of poles, the value of poles, and then here this thing is to plot out the plane lah. What is that? The graph. And to plot out S-plane, we use this this coding command, and you can put S grid to let the graph to have a grid of S-plane. Okay, so I'm going to run it. So X label, Y label is just the labeling for the X-axis and Y-axis. Okay, so we are going to wait for the graph to keep up. Okay, so here's our pole diagram. And here's our 0, 0, 0, and our pole. Yeah, so this is the result. And we are going to the coding part again. So not the code part, it's the output part. Okay, output part, it will give us the HD, our equation, and then it will list out the N and D and then sub everything. So A is the value from the numerator here. 10, the S power 3, the number is 10, S power 2 is 22, S is 460, and without S is 32. And same goes to here, it will automatically let you to get it. Okay, and this is our post constant, and then we'll get the final thing and our result. Okay, so here's question 3. And lastly, we are going to our question 4. Alright, question 4, we are asked to use MATLAB to find the poles and zero of the given function, this one, and then find the inverse Z transform of x, z, and also plot the Z plane and determine its stability. And we assume the system is causal. Okay, so let's go to our question for coding. Okay, so same thing, N and D, numerator, denominator. Okay, we sub in the value from numerator and denominator. Okay, numerator is -4 and 8. Denominator is 1, 6, and 8. Put in, and then we put this one to get the poles, the value of poles and holes for the poles and zero for the system to remember it, and then later it will plot out for us. And this is our equation and syntax, which means we are in Z domain, and later it will plot out a Z plane for us. And this is the function, the command to plot a Z plane, and we can run the system. Okay, so for a moment please. I think it's already out. Oh yeah, it's already out. So this is our zero and post diagram, and you can see that here we have 2 0 and 2 poles. And next we are going to see our output and also the part ABC right in our word file. Okay, question 4, our coding, our output. So you can see it code the exact first, and then it inverse for us the function. This 2 is the answer, either take this one or this one, and residue, poles, and constant. Okay, for part A, we are asked to get the zero and poles. So you can see from the output, right? Actually, we are given this. Wait. Okay, we are given this one. And then we will use some calculation to make it to the last step and get our zero and poles. Zero means our numerator, poles is our denominator. So from here, z equals to 0, z equals to 2, z equals to -2, z equals to -4. 0 and poles, done. And then next we're going to check the inverse lag transform from our output is here. This one. So we just put in our answer, and also your poles you can check with this one. Yeah. And then so your poles is actually the same. Okay, so part C is the thing. We need to check the stability of the system. So in the question we are asked to assume the system is causal. So for a causal system, Hn equals to 0 and n must be bigger than 0. Therefore, the region of convergence will be at right-handed and form an outer ROC diagram. So I can explain what is the right-handed thing. So okay, like imagine this is our unit circle, okay, and then if it wants us to be the right-handed, which means we need to shaded the right part, which is like this. Okay, so after you shade the right part, you will continue with here, but it's outer lah, because the right-handed is means like the value, your poles values right-handed. So right here you will put like this and you get a outer ROC. If it's left-handed, this is right hand. This is left hand. Okay, if it is left-handed, it will become inside the poles. So this is some explanation on right-handed shading and left-handed shading. Okay, so continue with our part. So after we draw out this, and then we plot in our poles, which is -2 and -4. So automatically, if you plot in -2, you need to plot a positive one because this is a circle. So you will have 3 circles. One is the unit circle, which is always at 1, your poles at -2, and your poles at -4. Okay, remember we say that when the system is causal, your ROC will be will be right-handed. So let's check with our poles with -2. So when it wants to go right-handed, so you will shade it here as the picture lah. And also for the -4, also shaded right-handed, same as the picture. I just draw some just let you to know. Okay, so after that we will get a diagram like this. So after getting this, you can start to determine your system whether it's unstable or stable. So for stable, your system, your unit circle must be touched or under the shaded part. So unfortunately, it is very clear that our unit circle, our 1, is not be shaded or be touched with the shaded part. So I can say that this system is actually an unstable system. So this is all of my lab test, and thank you for listening. Bye bye.